Today we're going to be taking a look at factoring trinomials in the form of ax squared plus bx plus c, and specifically when a is greater than 1. So I have a separate video for when a is equal to 1, so it's just like a trinomial in the form of x squared plus something, something, something. But here it's going to be like 2x squared or 3x squared or something where that a value is not 1. And there's a lot of different ways that you can do this. I prefer the AC method, which I'll explain in a second. But then there's also guess and check is another way of doing this. Guess and check. And guess and check is exactly what it sounds like. You guess and you check. You guess to see what it's going to be, what the two binomials are going to be, and then you check that by multiplying it back out. Because what we're looking at here is, if you think backwards, if you had something like this, like 2x minus 1 times 3x plus 2, what we would do is we'd multiply this out. 2x times 3x is 6x squared. 2x times 2 is 4x. And then we'd multiply this out. Negative 1 times 3x is negative 3x. Negative 1 times 2 is negative 2. You'd add in the middle term. So we'd have plus x minus 2. So we'd end up with this trinomial. When we're multiplying two binomials, we get a trinomial. So what we're trying to do now is we're trying to work backwards into this form. So the guess and check method is seeing that this first term here is 6. So then you think about, well, what could that be if I'm trying to get back to 6? So it could be 6 and 1 potentially, so 6x times 1x, or 3x times 2x. And then the problem though with that is, so then you have to look at the end. So negative 1 and 2, we want it to multiply to a negative 2. So it could be something like 1 and 2, 1 and positive 2, or is it positive 1 and negative 2, or does the 2 go with this term and the negative 1 goes here, or is this positive and this is negative? You see what I mean? Like, the guess and check method can get pretty, I don't know the correct word of saying, pretty unbounded, where you could really go down a lot of different paths and maybe waste a lot of time. So that's the guess and check method. I'll use the guess and check method just to show you, like, there are certain scenarios where guess and check would be a pretty good method to use. But like I said, I'm going to use the AC method. So here's what the AC method is. So we're in the form of ax squared plus bx plus c. This is a, this is b, this is c. So the AC method is taking the a term and multiplying it by the c term. So I'm looking for two numbers that multiply to negative 15. So 5 times negative 3 is negative 15. And then I want two numbers that are going to add up to negative 14, that middle term. So two numbers that add up to, or multiply to negative 15 and add up to negative 14. That's what I'm looking for. So that's going to be negative 15 and 1. And I'm not going to really mess around with a lot of the wrong combinations because I got quite a few problems in this presentation here. So I don't want to waste time filling it up with wrong combinations. So I'll try to find I might accidentally do one wrong, but I'm going to try to find the easiest one, or the most straightforward route right away. So negative 15 times 1 is negative 15. Negative 15 plus 1 is negative 14. So those are my combinations that work. So here's how we do the AC method then. I found my combinations of numbers, negative 15 and 1. I'm going to bring down my a term, so that's going to be 5x squared. I'm going to bring down my c term, so that's going to be minus 3. And I'm replacing this middle term with my two factors that worked. Negative 15 times negative 15x and positive 1x. And I'm putting x here because negative 15x plus 1x is negative 14x. What I'm doing is I'm just breaking 14 up into two numbers so I can now factor by grouping. So I'm rewriting that middle term as a sum of two other numbers. And that allows us to now to factor by grouping. And sometimes this method, AC method, is called a factor by grouping method. So now we're going to group 15x squared minus 15x, factor out the 5x. This is just grouping. And then I'm left with x minus 3. In the second set of parentheses, I have plus 1x minus 3, or 1x minus 3. I don't have anything to factor out, so I have to factor out something, and that's just going to be a 1, and that's going to leave me with x minus 3. So I'm factoring out the x minus 3, and I'm left with 5x plus 1. So right here, after I write this line, this is now factor by grouping. If you struggle with factor by grouping, that's a lesson that you need to go back and watch to understand factor by grouping, but AC method just uses a lot of grouping methods there of just getting that middle term. So the struggle here is getting this middle term to break up so then we could use the grouping. So then this is factored. And you can check it by multiplying this back out and then seeing if it matches up. Let's take a look at number 2. So number 2, I'm going to multiply 2 and negative 9. So that's negative 18. I want two numbers that multiply to negative 18 while also adding up to negative 7. So that's going to be negative 9 and positive 2. Negative 9 times positive 2 is negative 18. Negative 9 plus 2 is negative 7. So I'm bringing down my A term. My A term's not changing. I'm bringing down my C term, and I'm replacing my middle term with the two factors that worked. So negative 9x plus 2x. Now that we have 4 terms, I'm going to factor by grouping. So in the first parentheses, the only thing I could take out is x. That's going to leave me with 2x minus 9. In the second parentheses, I don't have anything to take out, so I have to take out something, and that's going to be 1 again, leaving me with 2x minus 9. Oops. And look at that. We have the same thing in parentheses, so I'm going to factor out that 2x minus 9, and I'm left with x plus 1. And there is our answer for that one. So far, guess and check wouldn't have been too crazy. I would have needed to think about how would two numbers multiply to 2, so that'd be 2 and 1. I think the struggle with guess and check, though, is knowing what the signs are going to be. Like if this is going to be, if this term right here is going to be the plus 9 or the minus 9, or does the 1 go with the 2 and the 9 goes with the x term? Like that's where guess and check might take up some time, where you're trying to match up with the combinations. So that's why I like AC method. It's just clean cut. You just boom, boom, boom. Here's the system. And you know you're not going to get stuck for a very long time trying to figure out what's going to work out. Where I think guess and check, there's a little bit of a no time limit kind of scenario. But I think AC method might take a little bit longer, but you'll get there at least in some sort of time frame. So number 3, we have 35x squared minus 16x minus 12. First of all, check for a GCF. In these last two, I didn't need to check for a GCF, like 5, 14, and 3. Nothing's going to factor out of 5, 14, and 3. And then 2, 7, and 9. Nothing's going to factor out of 2, 7, 9. So 35, 16, and 12, still nothing to factor out, but just getting in that mindset of like, look for something, because that looks kind of ridiculous. 35 and 16 and 12, like, oh, this is going to be a mess using AC method. So using AC method, I want two numbers that multiply. So I got to do 35 times negative 12. So I want two numbers that multiply to negative 420 and add up to negative 16. Since I know that I want my front two numbers to multiply to 35, it wouldn't be the worst idea to just maybe explore guess and check for a minute, just to see if you can get the combination to work, because we want 7 and 5, and I want two numbers that multiply to 12 on the end. So this could be either like a 4 and a 3, or a 6 and a 2, or maybe this is 3, this is 4, this is 2, and this is 6. So there's some combinations there that could work out, like maybe 12 and 1, but I don't know. That seems like it would be kind of weird if it was 12 and 1. But it's not the worst idea to just maybe explore this for a minute and just have like a sidebar with it and see if maybe you can get the combination pretty quickly, because we know we need two numbers that multiply to a negative, add up to a negative. So we know one's going to be a negative, one's going to be a positive. So I don't know. Let's just see if I can get this within like 30 seconds or so. So 7 times 5 is 35x squared. 7 times 3 is 21x. Negative 4 times 5 is negative 20x, and then negative 12. So you see how that middle term didn't work out. 21 minus 20 is only a 1x. I wanted a 16x. So that wasn't it. And even if I flip the signs, that's not going to change anything. But maybe if I flip the numbers, let's see if that works out. So then that would be 7 and 4, which would be 28x. And 5 and 3, which would be 15. So we're getting closer, but still, this is exactly what I don't exactly like about guess and check, is because you can just kind of wastes a lot of time just trying to find that combination that might work out. So, but it's not like impossible or anything. So using AC method, just so while we're talking about it. So using AC method, to get the answer, I'm gonna erase this so it doesn't get too messy. And you could keep doing cast and check if you want. If you wanted to keep trying to mess around with the combinations. So in a number like this, like 420, two numbers that multiply to 420 and add up to 16, what I would do is I would just go through the big numbers, like 420 divided by 20, that's 21, not going to work. And then I would just keep trying things like that. Like, so 420 divided by 30, that's 14. So, okay, there it is. 30 minus 14 is 16. So now it's just a matter of messing with the signs. Is the 30 going to be the negative, or is the 14 going to be the negative? But we want it to add up to a negative, so the bigger number needs to be the negative. So this would be our combination. So I'm going to bring down 35x squared and replace negative 16x with negative 30x and 14x. And it doesn't matter the order when you're replacing that middle term. Then minus 12. Factor by grouping. From the first set of parentheses, I'm going to take out a 5x, because it's x squared and x. So I'm going to get 7x minus 6. 30 divided by 5 is 6. And then the second set of parentheses, I'm going to take out a 7. I'm sorry, not a 7, a 2, because it's going to be 7. A 2. So it's going to be 7x minus 6. So then there is our common factor, 5x plus 2. So going back to that guess and check that I was talking about, I had the 7x and I had the 5x here. Or I had it flipped around. But then I went through 3 and 4, it didn't work, so then my next guess would have been like 6 and 2. But again, like, it's kind of hard to tell right away if this is going to be the 2, this is going to be the 6. Then even on top of that, is this positive? Is this negative? Is this a negative? Is this the positive? Then even flipped around, is this a negative 6? Is this a positive 2? So there's just a lot of combinations that you'd have to play around with, but it's not impossible and might have honestly been a quicker route for something like this. But this is a little bit of a bigger number that you typically won't see a whole lot. So hopefully that one was okay. Let's move on. Did I skip a number? 3, 5. Skip number 4. So on this next one, factor 15x squared minus 42x plus 27, right away you're like, oh my goodness, 15 and 27. I'm going to have to multiply those two. But look for a GCF. Does 3 go into all of these numbers? 3 goes into 15, 3 goes into 42, 3 goes into 27. So factor out that GCF of 3. So I'm dividing each of these numbers by 3, which is going to make this way easier to manage. 15 divided by 3 is 5x squared. 42 divided by 3 is 14, so minus 14x. And then 27 divided by 3 is 9. So now it's factored, or I'm sorry, now the GCF is factored out. So now using the AC method or guess and check if you wanted to, this wouldn't be the worst problem, but just don't forget about this GCF that you factor out as you go through the process. So I want two numbers that multiply to 45 and add up to negative 14. So two numbers that multiply to a positive 45 and add up to a negative 14. Positive 45, add up to a negative, so both numbers need to be negative. So it's going to be negative 5 and negative 9, because that's positive 45, where negative 5 plus a negative 9 is negative 14. So ignore that GCF of 3 for a minute, and then let's just finish up the factoring process. So 5x squared, replacing the middle term with negative 5x and negative 9x. Bring down the plus 9. I'm going to group. Careful with this minus sign here when you're grouping. That negative sign needs to be tacked on with that negative 9x. So in my video on factor by grouping, I've talked about this, where there's two ways of doing this. You could do this, but some people don't like that. So then what some people encourage their students to do is that, like, just plus, make this a plus, and then put the negative inside there. Either way, you get the same thing. Factor out the 5x from here, x minus 1, because I took it out 5x. 5x divided by 5x is 1. Took out 5x from 5x squared, so we're left with x. Then here, I have to take out negative 9, because this is a negative 9. Leading negative always gets factored out. They're both 9s, so take out negative 9. That's going to leave me with a positive x minus 1. So then I'll be left with x minus 1 times 5x minus 9. So if you use factor by grouping, this wouldn't have been, oh, and I forgot the 3. The 3, gotta get that GCF. So using guess and check here wouldn't have been the worst exercise because it's two numbers that multiply to 5. So you know it's going to be 1 and 5, and then it's just messing around with where does the 1 and the 9 go. Like, would it be 5x minus 1 or 5x minus 9, x plus 1 or x plus minus 9? And we know they're both negative because they have to multiply to a positive 9. So that makes it a little bit easier. So guess and check wouldn't have been a crazy exercise there. I like to play the safe route. I just like to go with the, let's just do a method, little system. I like systematic approaches to things. Number 6, factor 5x squared plus 17x plus 10. Let's go through this one. So for GCF, first of all, no GCF. So I'm going to do AC method here. 5 times 10 is 50. And then we want two numbers that multiply to 50, add up to 17. Two numbers that multiply to 50 and add up to 17. It's kind of an interesting combination. Add up to 17. So that one, I'm not able to think of anything. So as I'm going through, I'm just doing, like if I'm in this situation where I'm like, I'm not sure what this goes to. I would do 50 divided by 2, that's 25, not going to work. 50 divided by, I know 3 is not going to work because that's a decimal. And just go through combinations of numbers. So I know 4 doesn't go into 50, then 50 divided by 5 is 10. 10 plus 5 is 15. 50 divided by 6 isn't going to work. 7, 8, 9, 10. 10 we already said was 5. 50 divided by 15, not going to work because 15 doesn't go into that. And then you get to like 50 divided by 25, and then we're right back to where we started with 2. So nothing's going to work. So we call this one prime. Cannot factor that trinomial. Cannot factor it. Number 7. Let's go ahead and do this one. Let's see what happens here. So we do not have a GCF. So I'm going to multiply. I want two numbers that multiply to a negative 144 and add up to a negative 7. So two numbers that multiply to a negative 144 and add up to 7. So this one's going to be interesting. So what I would do when I'm trying to go through the combinations, I would just start going 144 divided by 2, 144 divided by 4, and try to start working it back. So like right now I'm at 144 divided by 8, which is 18. So 18 minus 8 is 10, so we're getting closer. So 144 divided by, let's say 12. 12 is 12, I knew that. So I shouldn't have even tried that. 144 divided by, let's try maybe 16 goes in there. Yes, it does. 16. 16 and 9. There it is. 16 minus 9 is 7. So two numbers that multiply to a negative 144 and add up to a negative 7 is going to be negative 16 times 9. So negative 16 plus 9 gives us back that negative 7. So there's our combination. This is the kind of problem where guess and check can really get you into some trouble. Because if you think about it, you need two numbers that multiply to 12 in the front end, two numbers that multiply to 12 on the back end. So you're going to be messing with 4s and 3s and 6s and 2s for quite a while until you can kind of get that combination. And it might be something that the more you do this, the more comfortable you get with factoring and how it shakes out. You might be able to find those combinations pretty quick. But starting off, it's kind of hard to understand like what's going to happen if I multiply these two numbers together, and then what's going to cause those middle terms to be what it is. So it might just take some practice. So I got negative 16x plus 9x, and where you put these do not matter. Just want to emphasize that one more time. Minus 12. Factor by grouping. First set of parentheses, I'm going to factor out a 4x. Leaves me with 12 divided by 4 is 3x, x squared over x. Minus 14 divided by 4, or 16 divided by 4 is 4. Took out the x. Then the second set of parentheses, I'm going to take out a 3. Leaves me with 3x minus 4. And there is our answer, 3x minus 4 and 4x plus 3. So guess and check could have really taken up some time there. On this next problem, I want to modify this a little bit. I think I threw in a couple extra pieces of information. So I'm going to call this 10xy squared plus 22xy minus 140. Like that. So I'm just going to change that around a little bit. There's two problems that I added in that 2 right there. So I could have made it 2 separate problems, but I'm just going to keep it like this. So when it's presented like this, first thing I want to do is I want to factor out a GCF. So a potential GCF could definitely be 2. Take out a 2. I cannot take out any variables because this is x squared, xy, but then this doesn't have any variables at all. So I don't have any variables that could be taken out. If I left it in this original problem, like y squared, like that, and this y squared here, I would take out the y squared, and then it'd be pretty straightforward from there. But I wanted to make it look, I think this looks a little bit more interesting. So I'm going to take out the 2. That gives me 5x squared y squared plus 11xy minus 70. So now go for guess and check if you want. Not a bad problem to use guess and check. But if I multiply this, I'm doing 5 times 70, which is negative 350, and add up to a positive 11. I want two numbers that multiply to a negative and add up to a positive 11. So two numbers that multiply to negative 350 and add up to positive 11. So we have to be careful with our combinations of numbers here. So 35 divided by, let's go for like 25. I think 25 is probably a good starting point. And there it is. So 25 times 14 is 350, where if I mess with the signs a little bit, if I make this negative 14, 25 minus 14 is positive 11. So I get my numbers that work. So even like in these intimidating situations where like, oh, 350, like this is going to take forever. 350 is divisible by 25. So maybe jump there, see if that works out, and it does. So that's what I'm going to use. So I'm going to, don't forget about this GCF. I'm going to bring down 5x squared y squared. I'm going to replace 11xy. Be careful here. This is why I kept it like this. 11xy, I'm going to rewrite this as 25xy minus, this is going to be negative 14, minus 14xy minus 70. Don't forget about that GCF of 2 as we go through this process. So I'm going to factor by grouping. From the first set of parentheses, I'm going to take out 5xy, and that leaves me with xy. Took out 5xy, and then, so that's going to leave me with xy. Plus, took out 5xy again, so that's going to be 5. 25 divided by 5 is 5. X and y are gone. Then the second set of parentheses, I can't take out any variables, but I could take out a negative 14. Yeah, I could take out a negative 14. Almost at 7, but yeah, 14 going to 70. So I'm going to take out negative 14. So that's going to leave me with positive xy plus 5. So I get the same thing on the inside. That GCF that we took out, so 2 times xy plus 5 times what the leftovers, 5xy minus 14. So when you're using guess and check here, if you did, xy, because I want x squared and y squared, so it has to be xy times xy, which would give me back x squared, y squared, and then you'd have to play around with two numbers multiplying to the 70 here which isn't impossible, 7 and 10, 14 and 5, so you can figure that out pretty quickly, but you just got to be careful with the signs if you're using guess and check. Number 9, negative x squared plus x plus 30. So this looks like a pretty straightforward trinomial. The problem, though, is this is a negative. So since it's a negative, it's a leading negative, I have to factor out that leading negative. So I'm going to take out the negative. Then now I just have a trinomial in the form of x squared plus x, sorry, not plus x, minus x, because I factor out a negative. So minus x minus 30. Took out that negative 1. That's a factor, so I have to take that out. So then now I'm left with this trinomial, two numbers that multiply to x, x and x. So now I just need two numbers that multiply to negative 3. I don't need to use AC method here. I just need to factor the trinomial. Just looking for two numbers that multiply to negative 30 and add up to a negative 1, which is going to be negative 6 and 5. So that's going to be minus 6 plus 5, because negative 6 times 5 is negative 30, where negative 6 plus 5 is negative 1. So done. I don't even need to use AC method because this A term is 1. A is equal to 1. So AC method is only used when A is greater than 1. Same thing with number 10. But what I want you to notice here is that this C term is 9. 3 times 3 is 9. 9 is a perfect square because 3 squared. This term is 1. This is 1 squared. This middle term is if I take 2 times 3 times 1. That will give me my 6. This form is called a perfect square trinomial. This is a perfect square trinomial. Perfect square trinomials are when we have the form of a squared plus 2 times ab plus b squared. That is just going to be equal to a plus b squared. So in this example, I have my a term being 1, my c term or my b term being 3, because 1 squared is 1, 3 squared is 9, 1 and 9, and then if I do 2 times 3 times 1, I get back 6. So in this form, I'm going to have x plus 3 squared. And if you just factored it, like just looking for two numbers that multiply to 9 and add up to 6, you would land on 3 times 3 pretty quickly. So you could also write this as x plus 3 times x plus 3. It's also a perfectly fine answer. Another form that perfect square trinomials can take is a squared minus 2ab plus b squared. And that could be in the form rewritten as a minus b squared. So if you think back to multiplying polynomials, like if you watched that video before, we did this type of exercise where you looked at a plus b squared. What does that do? Two binomials being multiplied together. But then we talked about that little shortcut there where you could just use this formula. Kind of useful for factoring, but again, not a requirement, because you could have just looked at two numbers multiplying to 9, adding up to 6, and then you'd have your answer of x plus 3 times x plus 3, where you could then say like, oh wait, that's the same thing, so I'm just going to write that as x plus 3 squared. So perfect square trinomials, not a requirement to know that formula or anything like that. It just might make the process a little bit quicker. It might make it a little bit easier. Like on this next example, 16x squared minus 40x plus 25. This is a one where if you use AC method, it would get a little messy. 16 times 25 is 400. So two numbers that multiply to 400 while also adding up to 40. Not impossible to find that combination, multiplying the positive 400 adding up to negative 40. Not the most impossible thing in the world, but 16 is a perfect square, that's 4. 25 is a perfect square, that's 5. And then if I take 2 times 4 times 5, 4 times 5 is 20. 20 times 2 is 40. And this is a minus sign, so my answer is going to be 4x minus 5 squared. And if you did do the AC method process or the guess and check process, you would end up with 4x minus 5 times 4x minus 5. But since these are the same things, we could just rewrite this as 4x minus 5 squared. So knowing the perfect square trinomial saves us a little bit of some time, but not a requirement again, because you could just use the AC method. And I think this is the last one. Oh, no, 2 more. So on number 12, factoring this one, nothing too out of the ordinary here besides the order. So just reorganize it. So the x squared is going to come first. Middle term is minus 17x, and then we have that plus 52. And then we're just looking for two numbers that multiply to 52 and add up to 17, negative 17. So multiplying to a positive, adding up to a negative is going to be negative 4 and negative 13. That's positive 52, and negative 4 plus negative 13 is negative 17. And I don't even have to use AC method, so I'm not going to bring down and replace. I'm just going to rewrite this as x minus 4 times x minus 13. Whenever that a term is just 1, you don't have to do the AC method. You can, you're just doing extra steps. Not necessary. And last one. I think, yes, last one. 14x to the third minus 36x squared minus 18x. Two things. I'm going to factor out an x. And I could also factor out, I'm thinking, a 2. So let's factor out a 2x from everything, and then we'll see what happens. So I'm factoring out a 2x. So I'm dividing each term by that GCF of 2x. 14 divided by 2 is 7x squared. 36 divided by 2 is 18, so minus 18x. And then minus 9. 18 divided by 2, we took out an x, so that's gone, so minus 9. This looks like a good AC method problem here. So 7 times 9 is negative 63, so two numbers that multiply to a negative 63, while also adding up to negative 18. And unfortunately, 9 plus 7 won't work out, so that means we have to mess around with the numbers a little bit, which isn't too far of a reach, because if you just do 63 divided by 3, because 63 is odd, so we just divide by 3, you actually get 21. So that's going to be negative 21 times 3 is negative 63. Negative 21 plus 3 is negative 18. Don't forget about the GCF. 7x squared. Replace negative 21x plus 3x. And then bring down the minus 9. Don't forget about the 2x. Factor by grouping. So I'm going to factor out 7x from the first set of parentheses. That's going to leave me with x minus 3. Second set of parentheses, I'm going to factor out 3. That's going to leave me with x minus 3. X minus 3, so we'll have 2x, the original GCF, 2x times x minus 3 times 7x plus 3. There is the factor. So this video was all about ax squared plus bx plus c when a is greater than 1, and all of the different potential looks that you can get, perfect square trinomials, some messy factoring where guess and check might be your better method, but hopefully you either connect it with AC method or the guess and check method to get through these problems.